Adding and Subtracting Rational Expressions Part 2, and we're going to start right where we left off, addressing Example 2, how to subtract this exact rational expression. So, since we've seen the process of this, I suggest that you pause the video and see if you can work through this example completely on your own. Okay, let's just follow the steps at our top right here. First thing that we need to do is factor the denominator, and now you're starting to see why this is your new best friend, or your best friend in college algebra, because it all comes back down to these factoring techniques. So let me start with this guy here, my first denominator. It is in descending order. I do not have any common factors. I have 3 terms, so I will factor this as a trinomial by setting up my parentheses and working that FOIL process backwards. Factors of my first, or x squared, go in my first places. I only have one choice of x times x. Factors of my last, which goes in my last place. Again, I only have one choice, a 1 times 3. And I want to end up with a positive 4x in the middle. So if my outside is a positive 3x and my inside is a positive 1x, those add to give me the positive 4x in the middle. So I have factored my first denominator, and I factored it completely. I cannot factor it any farther. And I'm just going to copy my numerator down. So let's look at my second denominator here. Same process. Descending order, no common factors, 3 terms, so I set up my parentheses for a trinomial. Factors of x squared, I only have one choice of x times x. Factors of 3, my choices are 1 times 3. And in the middle, I'm looking for a positive 2x. So if my outside is a positive 3x and my inside is a negative 1x, those will combine to give me a positive 2x when I add them and a negative 3 when I multiply them. So I have factored my second denominator and I just copy my numerator down. So I have finished step number 1. So to come up with my least common denominator, I need to see what factors I do have in common. And notice I have an x plus 3 in common. And what factors I don't have in common. And notice I have an x plus 1 here and an x minus 1 there. Those are my missing pieces. So I need to multiply those missing pieces by my opposite fractions. So this guy has an x plus 1. Let's put it over here in this guy. This guy has an x minus 1. I need to put it over here in this guy. Once I do all of this multiplication out, I can move on to my next step of adding and subtracting my numerators, and I should have my least common denominator. So let's look at the denominators first, because that's still our focus at this time. I have an x minus 1, an x plus 1, and an x plus 3, minus an x minus 1, an x plus 1, and an x plus 3. So since all of my factors match exactly, that means I have a least common denominator. The only change I did from this step to this step in my denominators was rearrange the order, and I can do that because multiplication is associative and commutative. Okay, now I have to figure out what to do with the numerators. And I have to do what this problem said. I have to multiply out my numerators. So I have to multiply this out here, and I have to multiply this out here. And notice both of those are binomials times binomials, meaning to multiply those out, I have to use that keyword of FOIL. So let's start with my left. X times 3x gives me a 3x squared. Outside, x times 5 gives me a 5x. Inside, negative 1 times 3x gives me a negative 3x. And last, negative 1 times 5 gives me a negative 5. In my second fraction, again, I'm foiling. X times x gives me x squared. X times 1 gives me a 1x. Negative 5 times x gives me a negative 5x. And negative 5 times 1 gives me a negative 5. So I'm finally to the point where I can put my two fractions together, where I can add and subtract my numerators. But let's go back to my steps here. In step 3A, it said if it's a subtraction problem, the high recommendation is to distribute that negative through the second fraction so you don't lose any negatives along the way. So let's see how that works with this specific example. Notice I am trying to subtract these fractions here. So that subtraction really means I'm going to this whole fraction there. And so I want to take this negative and I want to distribute it through my whole fraction. Now with fractions, I can put the negative in the middle part of my fraction with my numerator on top and denominator in the bottom. Or I can take my negative in the numerator over the denominator. Or I can take my negative and just put it in the denominator. But you do not ever put it in both the numerator and the denominator. So what I'm doing here is I'm taking the negative from the middle part of my fraction and I'm moving it to the numerator of my fraction. So I'm going to take this negative and I'm going to distribute it through all of these pieces in my numerator part of this fraction. So that makes this an addition problem, and that changes all of my signs here. I have a negative x squared, a negative x, positive 5x plus 5. Now I no longer need these brackets around there because I have distributed that negative all the way through. So finally, I can add my numerators. I can put my numerators together. So 3x squared minus x squared gives me a 2x squared. And all of these x's I can put together. So 5x minus 3x gives me a 2x. And negative x plus 5x was a 4x. So 2x plus 4x gives me a 6x. And my negative 5 and my positive 5 actually cancel out. So when I add or subtract my numerators, I get this here, 2x squared plus 6x, and that is all over my least common denominator of x minus 1, x plus 1, and x plus 3. So I have finished step number 3, where I now officially just have one fraction. Now I want to see if I can reduce this fraction, and I do that by factoring my numerator. If I look at my numerator, I actually notice I have a common factor of 2x. If I take that out, that leaves me with x plus 3. And notice what happens when you put that over your least common denominator. You get identical factors in the numerator and in the denominator. So those factors end up canceling out. And we have our final answer of 2x over x minus 1 and x plus 1. So I have shown you a couple of examples of how to add and subtract rational expressions. And don't forget, it all goes back to these rules here, where you need to focus on your least common denominator first, and then put your fractions together, and then try and simplify it by factoring the numerator first.